Welcome everybody. I'm José Martínez Ferrándiz, and alongside Álvaro, Antón, Jesús Sánchez Mollá and Daniela Armador-Cano, in this video we will introduce you to the atom, its subatomics, particles and the main models. Matter is made up of pure substances, known as chemical elements, that cannot be broken down into simpler substances. The atoms are the smallest parts of an element, which still has the same properties as the element. Because of this, we can use different techniques to identify the atoms and know which elements are, such as electroscopy, which measures the spectrum of the white light, casted by an atom when it gets heat temperature. The spectrum are different in each element, so this can be used to identify them. Another method to identify elements used in the 19th century was the use of electronic shocks of gases utilizing a charge tube. A gas discharge tube made up of container filled up with low pressure gases, an anode and a cathode. However, it was discovered that this resulted on a sudden fluorescence in near the cathode, which was later used to discover the electrons.
Atoms are made of subatomic particles, or also called elementary. For this reason, atoms are not indivisible, but are made of these particles. There are three types of subatomic particles: the electron, the proton, and the neutron. These three different subatomic particles have different electric charge. The electron have a negative electric charge, the proton have a positive electric charge, and the neutron doesn't have an electric charge. In 1897, the physicist Thomson published the results of his experiment with cathode rays, discovered by Placker and Hittorf in the mid of 19th century.
So first of all, an atomic model is a structural representation of an atom which explains its behavior and its properties. Thomson's atomic model explains two properties of atoms. First of all, electrons are particles which are negatively charged. Atoms are normally have neutral charge, but they can acquire electric charge in certain conditions. The principal characteristics of Thomson's model resume in these 5 points. Thomson discovered electrons through his experiments with tubes with cathodic rays. This model of atoms is formed by electrons charged negatively embedded in a positively charged sphere, as in raisin pudding. Atoms are evenly distributed all over the atom. The atom is neutral, so that all the negative charges of the electrons compensate with the positive charge. Electrons can be ripped off an atom. Now we're going to talk about Rutherford. Rutherford's model established that the atom has central nucleus in which the positive charge and most of the mass are concentrated. The positive charge of protons is compensated with the negative charge of electrons which are found outside of the nucleus. The nucleus contains thereupon protons in an equal number of two electrons of the atom. Electrons are found in the cortex and orbit by electrostatic force.
However, if electrons orbit around the nucleus due to electrostatic attraction forces, this means that they will eventually fall down to the nucleus due to the loss of centripetal energy over time. So Bohr decided to get rid of this problem by applying quantum mechanics to Rutherford's model. Bohr stated that electrons can be found orbiting around the nucleus in defined orbits or energy levels without emitting or absorbing energy. So energy levels can only have a specific amount of electrons in them, and electrons can change orbit by absorbing or emitting enough energy through the use of quantum acceleration. This succeeded to explain how single electron atoms produce their spectrums but fade when more electrons were introduced to the system. Our current model can explain how every spectrum is produced and also introduces neutrons to the nucleus. But Heisenberg's uncertainty principle and electrons wave-particle duality make us have to scrap the definition of defined orbits and make us adopt a new term, which are orbitals, which are regions of space where it's most probable to find an electron at any given time. So much for today's video. Thank you so much for watching. I hope you enjoyed it, and a big thank you to today's collaborators. By the way, you can find in the description down below a link to a document where you can find expanded information about this topic if you're interested enough. See you next time.